Hey there, this is Jin, and welcome back to another coding solution video. And today we gonna look at the edit distance. So basically, it wants us trying to find the minimum step using three kind of operation to achieve another word, another string to one string to another string. So I draw something depending. So you can see we have a brute force solution for this. So for example, if we have a string of two letters, and it need to convert to whatever strings, right? So we're starting with the first string. We have delete option, so it ends with empty, and the second solution insert, so end with two letters, and replace, so remain one letters. And after that, we adding counter the other string, the next string into the loop. But the other string will counting three more for each situation object did. So it end up with two letters. It end up with 9 totally combinations. It could be duplicated. So well, for this brute force, we just uh, sort using we made every kind of combination, so it's gonna achieve exploitation time. Roughly, it's gonna be 3 power of n times. So that's terrible. Well, since it has a duplicate situation, we can sort of way to improve that. So that's gonna be called dynamic programming. The name for that, basically to use a memory to remember the duplicate situation and reuse it again and again. But let's just use the brute force solution for this problem and see what we can achieve. So there. So we have word length of the first string, word length I, and second word length string j, and we recursively trying to solve this problem use recursive function. So first we have the recursion function. We have the input, the first string and second string, and also the first and second strings length represented by I or j. So if either string length is 0, that means we just add or delete all the numbers, so we can achieve the other string. So that's gonna be easy. So and also it's easy to return. But the other situations we're gonna use a counter to count the answer. So we're starting with 0, and then we're gonna check if the words. So let's back to the pen. Here we have 3 situations depend on what letters we have. So first we have insert. If we insert the situation to make that characters equal to the second word. Of that we gonna move forward, so we're gonna use the j to -1 to see the last second of the second string. Or if we delete one string from the first string, that makes the first string equals to second string, so we just move the first string's index forward and replace, basically we're gonna change the all the strings last string, so we move both index towards. Alright, let's keep working on the so yeah, this is the replace situation. So the string is the same. Basically the counter is going to be the, if the same, we don't considering the counter, so we don't change the counter. So the counter is going to be the recursive rate to be the next forward letters in the string. And else, if the characters are not the same, so that makes 3 different situations. And the counter is going to be the minimum, because we want the minimum state. It's going to be the either insert situation, so this is a replace situation, and the other, that's the replace situation and the insert situation. So yeah, because it is not the same, so we have to add 1 to the counter and finally return the counter. And see, for this situation we're gonna get the time limit exceeded. So because it is a recursive function, then after 20 letters long of a string, it's gonna running for too long, so we cannot get achieved answer. In able to improve, let the computer run in time, we have to do some improvement. So now we can using some technique called dynamic programming. There we go. We are going to adding a memory dynamic programming memo into this function. So we call the DP, and the DP size is still going to be the I+1 in the X and the J+1 in the Y. And we're gonna fill the DP with -1. And also we're gonna pass in this DP table into the recursion function. We're gonna using this DP table every time we use it. Too many comments. There we go. And if we get the DP, of course we're gonna return it as the result. We don't have to calculate it again. That gonna save sometimes. And then we're gonna pass in DP in every recursion function. here. 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 And also here. And instead of returning a counter, we can just return the last DP the state of the minimum moves we change to the string. That's gonna saving a lot of time and able to pass this code testing. Just submit, and there you goes the edit distance. So basically, we scale down the time complexity from the expansion time from big O 3 of n to n square time. Looks like it.